Hey, this is John McBride with Rocky Mountain Unmanned Systems. What we do here at Rocky Mountain is create solutions in the thermal world. So the idea around Rocky Mountain is to provide for not just public service and rescue and search and rescue and police, but to basically get the inspector guys on board with this stuff too. So if you're this presentation will be kind of focused around an inspection side of things, more so than doing police and search and rescue, even though we cover that for just a minute in this presentation. But for the most part, it'll be going through the ability to do mapping, some of the things we're running into and issues that are out there right now, and we'll discuss the current stuff that's available today on trying to do that. Okay, so what we're going to be talking about specifically today is the use of thermal drones or thermal cameras within the drone community and how to apply that. The objectives that we're going to talk about today, basically what is a thermal camera? I think that just in general a lot of people are not quite sure exactly how they work, what they do, how they're going to perform for them, and what they're going to be capable of doing. We're going to talk a little bit about the XT performance, so that's the standard XT, the advanced radiometric XT, the FLIR View Pro radiometric, how we're able to get some of the data off of that, and maybe make some maps or inspection stuff. Some of the images that are coming through as far as using for mapping and some of the solutions and relative information that we're able to put together for the mapping part. And then where we are today as far as these complications that we have, difficulties in mapping, and why we see so many different examples of great maps and great stuff, but who really knows how to do it. So there's not very many people with that. And then we'll follow up with some questions at the end, and I'll try to answer as much as I can. You're more than welcome to stay as long as the questions are relative to the presentation, and I'm happy to hang out for even longer than the 1 hour that this is scheduled to answer as many questions as possible to move forward in whether you should purchase, buy, I have, or what to do with that information. What is a thermal camera? So the thermal camera is a way that we are able to look at in an infrared spectrum that shows infrared radiation. That radiation is then transposed to a false color palette, if you will, so that we humans can actually visualize what the camera is actually seeing. The reason why it looks like this in most thermal cameras, where we have color palettes such as black hot, white hot, the fusion, which is what is pictured here on the right, all of those are a representation of what the camera actually sees. When we apply that false color, we can change a little bit of the dynamics of how it's registered or coming through, so that in a general sense we have that ability to see, and I'm not sure exactly which way is the best way to explain it, but how to see it so that our eyes can see it. If we're not using most of the time not using any kind of relative false color like that, then we don't see anything. There's just data there. There's nothing else. It's just data. It could be relative to temperature. It could be not relative to temperature, but there is data. Every pixel has a little bit of data there that is using that infrared radiation and transposing that. The traditional way that we usually do thermal imaging, and I'm pretty sure there's a lot of people that are pretty familiar with this, is we use a handheld imager. These guys will walk around. They usually are typically not more than 10 feet away from what they're trying to measure. But if we take a look at that picture on the right at the top, we can see that there's some relative temperature change of 62 degrees Celsius all the way down to 25 degrees Celsius. And in the one on the bottom right, we've got 823 degrees Fahrenheit to 60 degrees Fahrenheit. And so what that does with the imager when we're close to something like that is that you're specifically imaging one portion of it or one section. If the emissivity values, which we'll go over, are slightly different, these numbers may or may not be relative to the actual item that you are measuring. So I'm just putting my little scribe right here over this section, over that. If that, where my arrow is what I'm measuring, that may be unrelative because of what it's made of than something like this right here that might be a piece of plastic. Even though it's identical in temperature, it's showing differently because of the way that radiation and the emissivity of that particular item is. So handheld imagers, they're usually used within very close range, close proximity. And having a slight understanding of how those work transposes into using them on the drone. When we get into different types of cameras in the UAS area and understanding how we do it, we have different types of cameras, ones that are non-radiometric and ones that are radiometric. The radiometric versions are what we call qualitative data. So that data there is just a relationship of color. There's enough, the next part, delta in temperature to see a difference. The color palettes that we're able to use, we can use that data that's visual data to basically represent the differences there. And this particular way to try and map or stitch together is difficult. And the reason why it's difficult is because between each picture, which is not normal with a handheld to try and tie together, you can have some variations in the pixel color that doesn't match with each other. So some of the standard stitching stuff, which is what we've been using like drone deploy and then processing it through Pix4D or whatever the case is, when you use standard color pixels, they actually kind of do a little bit better putting those things together and stitching and 3D mapping and whatnot. But it's difficult to try and stitch in 3D when we do not have or even in a standard mosaic, when we have so many color variations between one picture to the next. We can almost associate that with being overblown or having too much, being too overexposed in a standard picture or being super underexposed. And that is 100% relative to what the camera sees in the picture. Because it is non-radiometric, it doesn't carry just the data that's needed, and it's hard to stitch those particular pictures together. These really do work well in search and rescue, police and fire, because they don't really care how much you are putting off in temperature to find you or to see you or anything like that. And in an inspection standpoint, we can use this information, if you will, to relatively look at something that may not look like the others. For an example, solar fields and whatnot. We can see here in this picture that there is enough delta there to basically make out individuals and people there, but they don't really, again, search and rescue guys are not going to care how much temperature you're putting off, or they're not interested in that as much as just being able to see you. But it's very important that we have enough delta, which is the variance in temperature that the camera can see, so that you are highlighted like that. This is not movie magic. They don't do that. It's if there isn't enough temperature difference, you will not be able to see somebody. They may just blend in like the rest of the actual image. One thing about this image here is that this was actually taken during the daytime instead of the nighttime. So thermal imagers do work during the day just as fine, but just on the shady side of the hill when this happened, we had cooler temperatures to create that delta, which is very helpful in order to see. So every picture that can be taken with radiometric basically has enough data there to possibly stitch together things or put together more data representation, but assigning it colors is done in post-processing. There is basically radiometric pictures that we can take with some of the cameras we'll be discussing a little bit later, but that's again, most of it's just raw data that we want to use. They use 14-bit data that has all of those relative numbers in there, or that each pixel has been assigned with data there to create an image for you to actually see. Because we're able to measure these things, there are some outside parameters that are very important to understand. Emissivity, reflective temperature, The distance away, we had talked about doing it with a handheld at 10 feet. Well, when we're doing it at 200 feet, you're going to have some discrepancies there, and it doesn't really matter. If you're farther away, it's going to be harder to get accurate temperatures. And some of the atmospheric changes that are out there. So our ambient temperature, our humidity, all of these things can be entered in to the actual camera so that we can get a more accurate temperature sensing or an accurate temperature measurement off of the things that are being radiated. We do have to remember that thermal cameras are not, I'm going to say this, thermal cameras are not a point-and-shoot camera for temp. When you see somebody that has that camera and it's showing a temperature on the side, all of these things we just talked about, emissivity, reflective temperature, distance, atmospheric changes, all of these things are relative to that particular item being or shooting your temperature or trying to get temperature off of. So I didn't have a really great example of this, but these numbers and values are really super important to being able to do or show or represent that. So with these values, on the left side, we have a picture here that is a radiometric picture. And the way we're able to mess with that on the right side is that we can change color palettes. We can change the way that the emissivity numbers are there. We have a temperature bar on the side that shows the range of where it's at, or basically the span of where it's at. We have a max and min temperatures on our little circle, and that's right here. This little circle is telling us basically in that measurement what is the high temperature, what the low temperature is, and what the average temperature is. These images were taken off the XT Advanced Radiometric, but they're probably not really super relative to the exact temperature because I didn't actually take all that time to put in values and numbers. But the image on the left is usually what you get when you take a picture with a radiometric, and the image on the right is something that has been manipulated later after. This is one solid image. This is not a built-up, stitched-together image. This is just one image, and one image is really easy to manipulate and everything else. The second you start taking multiple images, that can be a little bit more difficult to do. On this picture here, what we're looking at is the top of a roof building. We can see in thermal, the black is being hot, white is the cooler temperature. I'm sorry, that's the other way around, sorry. White hot on this one, black being the cooler temperature. And as we took this image is also a radiometric image, so the data is there, but the way I can see it is because of that false color tying into the actual image, so I can actually even see what's going on. When we look at this in comparison, we went out and actually took this image. The company was kind of like surprised about some of these other areas here up in this section right here, to where the pipes were causing, or the sun was causing some shadow down on the ground. Because when they first initially saw it, they thought, well, there's not that many pipes up there. What's going on? So even shadows can be relative to what your images are going to see, or what you're trying to image when you're trying to stitch together. So those can also confuse any kind of stitching or mapping. Is just the shadows of things, or the different directions that you're actually taking the shots. This picture of the solar field, which should come up here in just a second. There we go. This one here is actually, as we take a look, also a radiometric picture. It was transposed as trying to be able to see what problems there were in this solar field. So right here, if we're taking a look on our arrow down on the bottom in the middle, we have a panel that seems to be having a problem. It just doesn't look like the other ones. I can then take this image, although it's radiometric, and try to transpose it and give it some value and numbers and try to get some temperature off of it. But when we look at this little spot right here, up here on this top right, you can see it highlighted right there, that little spot is actually a reflectance of the sun. So that's the sun reflecting off the panel and not an actual bad panel. So we don't look, it doesn't look like across the board we have very many problems in this particular solar field. It looks pretty good. Everything looks good. But there might be something, that one panel that just doesn't quite look like the rest of them might be something that need to be investigated. Okay, let's talk a little bit about the DJI XT performance and what it is. Okay, so the DJI XT, when it first came out, they basically said it was not capable of doing radiometric. The radiometric for most people means that I can see temperature on the screen. So that must mean it can do radiometric. Well, yes and no. The radiometric side of things are being able to dial in some of those preset or those numbers that are very important before trying to get a temperature. So there is temperature information that is relayed on there, but in order to kind of create a way to do this and make it fly and make it go and come up with a way to use thermal on the drone, DJI and FLIR basically were able to put this together, but it's not specifically a radiometric version. Yes, it does temperature, but please know that there is that the issue there is the plus or minus 20 degrees Celsius on a standard performance XT. Plus or minus 20 degrees Celsius. So some of the questions that I get over on the XT itself. It still utilizes a Tau 2 core. The Tau 2 was initially an OEM product made by FLIR. The Tau 2 is used in the FLIR View Pro, it's used in the XT, and it's used in a number of military even versions of the FLIR camera, or the cameras. Some of them are even mounted on the front of an Apache. So the Tau 2 core is a really good unit, but the sensors are slightly different within those cores. So the Tau 2, people usually get a confusion because they see a Tau 2 that has the sidebar with temperature and it shows a relative number on the side, you know, as the thing is moving around. And yeah, that is a feature of the Tau 2. But in order to put it into the XT, they didn't necessarily put that on the side, but you're able to do other things with the XT that the Tau 2 cannot do, the standard core cannot do. And one of them is isotherms. Isotherms, which is not something that the Tau 2 can do. So, or the standard core Tau 2. The resolutions in that core version, 336 resolution and 640 resolution. Sometimes when I get the questions on which one should I use, well, it's just like 720 to 1080. There's no difference right there. One is slightly got more information than the other. So in other words, if you're looking for somebody that's possibly smoking a cigarette, you may not be able to see a cigarette at 300 with a 336 at 100 feet, but with that many more pixels, you might be able to see a cigarette at that height. What products does it currently work on, the XT? Well, we've got the Inspire, obviously, the one pictured on the right. We have the M100, and we have the M600. The announcement of the brand new Inspire 2, not too great for the XT, if you will. The XT is not capable currently, I don't know if it ever will be, to be able to be used on the Inspire 2. It's kind of a bummer, but that's, you know, that's one of the things that they had said they were going to be able to be capable of doing, but I think they basically just need to make a hot rod version of the Inspire 1 and keep the Inspire 2 as a cinema type thing. It does work really well on the M600 though, so small payload, small package, small camera, long flight times. The standard XT, we did answer a little bit about the question, is it radiometric? Is the XT radiometric? Well, it does carry data, it does output a temperature, but to do temperature correctly with that plus or minus 20 degrees, you have to be able to input some things in order to do that real time. And one of the other questions I get so often is, why is it so much more expensive than the standard Tau or the standard FLIR or the FLIR View Pro? The expense comes into the ease of use. We'll go through and show a couple of things here on how that's going to work out for us as far as the use of it. the integration into the DJI Go app, the capability of running isotherms, the ability to do a lot of the other things that inputting your emissivity values and stuff like that are not capable of doing on the FLIR View Pro. So it is a lot less expensive when you don't have to put as much software and hardware into the system. Some of the different lens sizes here, we've got on the top, the way they come on the XT, 640 by 512, you've got a 7.5 millimeter, 9 millimeter, 13 millimeter, and a 19 millimeter. The field of views are kind of associated with height. So depending on how far you have to be away from something, a 19 millimeter is typically recommended at a 32-degree field of view. That is so that you're not so close to things that might be very pertinent. And this also works pretty good in the search and rescue platform because they can fly a little bit higher and still get some detail down on the ground. The widest field of view on a 640 is a 7.5 at 90 degrees. When you drop down, let's just take a look at the 13 millimeter for an example. So the 13 on a 640 is 45 degrees, and we get down to a 336, which is the next number down at 25 degrees wide. We basically have cut that in half due to the resolution. So when you do call Rocky Mountain Unmanned Systems and ask for an XT and you're set on having a 13 millimeter, please keep in mind this chart on the field of view that you're able to see. We do have some recommendations if you're considering buying a 336 versus the other. Right here we're talking, kind of showing a comparison. This is a quantitative data. We're not showing anything that's really special with temperature, but this is a good way basically to show a representation of what you can see with a FLIR and what you can't see with a FLIR. We can see some water damage there that normally you wouldn't be able to see with your normal camera. And that doesn't have anything to do with temperature or radiometric data. This is a picture of a farm that we did. I actually did map this together. This wasn't one image. This is about 42 images. And when I put this together, I processed this in Photoshop. It was originally, like I said, a radiometric picture that was done in black and white, although I took the pictures in a different color palette. That's how it's saved. But without being able to stitch radiometric data and only doing it in Photoshop, Photoshop does not use any of that metadata whatsoever. It is simply trying to match pixels and the edges of things. That's it. And so sometimes you can get a really, really messy stitch because of, again, a little bit of difference in resolution, or not too much detail in resolution, and as well the different colors that might pop through with different shades, the shades of it. But this is a radiometric picture. Just doesn't have any data in there because of the way I actually stitched it. So the DJI XT Advanced Radiometric, what that's really cool to do is being able to actually use the tool to correctly measure temperature in real time, correctly, is that we're able to input some of those numbers. Every item within the scene that you're looking at has got a different emissivity value, and that's a really, really important thing to know. So when you're looking at human skin, or you're looking at a piece of metal, or you're looking at a piece of shiny metal, or a piece of wood, those temperatures, you can't just move from one type of product or one type of radiation to a different type of radiation and expect the camera not to make mistakes, because that's not the way it works. So remember, it is not a point and shoot camera for temperature. It is not. Some of my more common questions I get on the XT-AR, what makes it different than the other one? Well, we talked about that. I'm able to put some different numbers and values in there to get a more accurate temperature real time while in the air. Are the images are exactly the same? The images are the same, but because of that extra data that is laid in there between each shot, your accuracy is better when you try to process it. Do I really need to take a thermography class? Well, since we're talking about the XT-AR and its capability of putting in those inputted numbers, it's probably recommended to kind of do a thermography class. Infrared Training Center, which is basically sponsored by FLIR, has a great class, and I know that they're shortly incorporating a UAS version of this. so that guys that are just doing UAS stuff will have a class and go from theory and understanding all the way up to doing lab testing and different measurements to basically be focused in giving accurate temperatures to your customers. The file types that are available on the XT are the JPEG-R, and the TIFF. The JPEGs are normally what we see, 8-bit data. It's only a picture, but when it's taken off and basically pulled from the sensor, we can then get a JPEG radiometric picture, and that picture allows us to kind of stitch some things together and manipulate and put it into FLIR tools, and basically it's for FLIR tools processing. The TIFF data is raw image data. Sometimes when you take a TIFF image with an XT, it just is gray shaded and there is nothing on the screen. It's nothing. Why? Because it's completely data. Well, Pix4D had been working with FLIR in order to come up with a way to stitch the images together, and they had found that using a TIFF type file, and that's just the raw data file, that you could basically stitch together TIFF data and manipulate it to be able to make 3D models. Here in the back we do have a advanced radiometric in the back here, and what we have, which might be a little bit difficult to see, is the advanced radiometric. And what I'll do a little bit later is actually go through some of these settings, but a lot of it's not going to make any sense to you if you don't understand, once again, thermography and how it actually works and translates into a temperature sensing. But right here on the screen is my box that shows basically that, I have a slow connection, huh? Basically my temperature box right here, and the temperature box can be moved around, not just that, but you can actually touch in different sections and move it. Let me just take this off, which is not capable of doing with the standard XT. So I can move that temperature sensing unit anywhere I want to, but there is a temperature that is coming through. Let me touch down here. There is a temperature that's coming through, but what the emissivity value of the table might actually be different than the emissivity value of my arm. So in the menu button here, I can actually change that. As we're talking a little bit again about the advanced radiometric here, our capabilities of being able to put in a lot of the values and doing real temperature in different spaces on the screen is what is mostly important to why we're able to do that. I mean on how we're able to do that to get really accurate temperatures between each shot. Once we take a picture, and I think I showed you guys the actual picture of the rooftop and all of the pipes that were on the top, well, you can't, again, get the same temperature data or the same accurate temperature when you're measuring the pipe versus measuring the actual rooftop, you know, the rubber part, the plastic pieces that are holding the pipe together. These are all different values, and those temperatures can all be relatively different. So do keep that in mind. Well, let's talk a little bit about that View Pro radiometric and what it is. So the FLIR View Pro has been a great camera for kind of a do-it-yourself setup, and it was basically FLIR being able to do that with the ability to put a camera that was not as difficult as the Tau 2 was, to put that camera and output it in the ability to make it fit onto a UAS, small unit, easy output. The digital output on the Tau 2 was a little bit more complicated. Guys that were using and understood the Tau 2 could pull that data off, and they were able to manipulate the data, but not very many. It didn't make that very easy for the everyday guy, you know. So the FLIR View was made, and the FLIR View Pro basically SD card Bluetooth capability. The View Pro R itself does carry radiometric data, does have the spot meter in the middle of the screen when it's outputting in video, which is analog video, not a digital video. And when you want to make any setting changes, you can connect it to the FLIR UAS app. From there, you can change color palettes, you can do a couple of different things, but the one thing to remember is that the app that the FLIR View Pro uses is not used for viewing, not like a GoPro. It does connect so that you can change settings, you can change different things within the camera, but it does have, you can turn on or off the spot meter and the different span of temperature that's on the side. On the other side of the camera are PWM functions. There's 4 of them. You can program those if you know what that means, pulse width modulation. Basically, that's the ability to use a standard receiver that's like connecting a servo so that you can change different functions in the camera, such as you can choose 3 different color palettes to switch between. You can choose the start and stop recording. You can choose a different scene. So you can program these 4 PWMs to do different functions within the camera. One of the big things that happened with the View Pro is being able to run the SD card. And since it's a radiometric version, we're able to gather the more accurate data on the radiometric side than just being a qualitative type setup. Previous picture had a shot of it being mounted to a gimbal, but here is a way that we managed to just kind of do a hard mount on the back end just so that people can experience some of the thermal imaging and trying it out and seeing how it works, seeing if it's really relative to them and whether or not stepping up to the more expensive XT was going to work for them or not. So this camera at the very top end, 640 radiometric, $4,600. And the top end advanced radiometric XT is $14,000. So that's a big jump in numbers and dollars, and sometimes, again, people don't find that very relative to try and figure out whether or not they need that. And that most of it is coming down to functionality and use. One of the other things that are very difficult to try to do with a FLIR View Pro radiometric is actually trying to tie in any GPS data when taking a shot. What's kind of awesome about using some of the flight controllers out there, such as the PixHawk, the PixHawk is capable of writing metadata to the actual image every time it takes a picture. So that is a way that they were able to do that. And this company, Action Drone, which we carry, does use the PixHawk for those setups as far as it being set up, but we're still, again, trying to get the ease of use in this section to be able to stamp that FLIR View Pro radiometric with the metadata so that you can use GPS data to map. Probably one of the big questions is, where are we today? Like, why is it that I can't just pull out my Drone Deploy app, put on my XT, and go start shooting some images? Pix4D is another company, Maps Made Easy, Autopilot. I mean, these are all just different kinds of companies that are ways to acquire the data. But I was at a Drone Deploy conference just a couple of weeks ago, and their profiles for flying the actual thermal camera are not quite there yet. And same with the others. I mean, it isn't like any of them make a very easy solution that's automated when out there flying around and taking pictures. So it usually takes about 1 second for the image to write to the camera or the SD card. It usually takes about a second. And that 1 second of time is way too slow for how fast the drone is going when using Drone Deploy or Pix4D Mapper or anything like that. There are some programs that you can slow the ship down, but it's still, if it's still moving, that thermal image could easily be blurred because of how much time it takes to write it to the card. And depending again on the data that's gathered will also depend on how the quality of the image might look after stitched. So some of those problems that we have, data acquisition right at the get-go. Maybe it's too bright out, maybe it's oversaturated with too much thermal temperature, and you're not going to get really good first initial pictures, or a big data set that's way too much, oversaturated with thermal. Doing that at night usually helps out to be able to see these thermal differences when using. Stitching them together, stitching in JPEG stitching or stitching in radiometric data stitching. Not very many people out there and not very many programs out there that are able to do that. Are they out there? Sure. But again, the standard guy of just figuring out how to do it right now, not so much. And we're going to talk about one company that has actually been able to figure that out. So actually having the correct data for temperature, the data specifically, emissivity values and everything else, when we're looking at mapping a very large space, remember, if they want to know what their pipe temperature is, that setup for the accurate data has to be done prior to, and we really highly recommend the radiometric version of the View Pro or the advanced radiometric to do this. And the height that you're at, and of course we just talked about the emissivity of different things on the ground. So remember, I'm going to say it one more time, not a point and shoot camera for temperature. It is not. This company, Spark Aerial, was able to basically stitch some images together for me. And Spark Aerial actually had the opportunity to go down to image a volcano. And I don't know, I can't remember how many images they actually did, but Radley there, and if he's joining my webinar today, I just wanted to thank him and his company for being able to stitch together radiometric data, which again is not easy to do in the manner of which these are set up right now. Radiometric data. So once they were able to stitch that together and he shot me some images of the volcano that they had done, I immediately sent him some pictures out to try and process and mess with on that. So these were manually taken, meaning that I flew the drone, took a picture, moved it, took a picture, moved it, took a picture. These weren't automated, they weren't run by Drone Deploy or anything like that. But after acquiring that data, Spark Aerial went ahead and stitched them together radiometrically. If we note real quick on the max temperature of 175 degrees on the top left, that's my max temperature, but on the right I'm showing 145.8. These are data numbers that are very important to put in and understand. And when we look at this original image, we can see that the spot meter is at 169.5 degrees. And that spot meter is right here. It's where that little X is. And spot meter in the next few images are not going to move, but we're going to change some data because of, again, emissivity data is being changed. So right now, there's been no modification to this image except to put color in, and that's it. When we go to this image here, we changed the emissivity to a different number. I actually moved it from 0.95 to 0.50, and the spot meter is in the same spot. And we got a temperature now of 127.5. Just by changing it an emissivity number, it has changed the temperature. And on this image here, our span numbers have changed. There's a little sidebar on the bottom, and when I imported this into FLIR tools and moved that around, now we've got some different numbers on the span, even though the spot meter changed or it stayed the same. So all of these numbers are relative to getting accurate data and temperature. When we're talking about using some of these images, again, I recommend the XT-AR to do it correctly, whether or not that you think you can map. Yeah, if you're going to do and provide a client data that is really important to them, that they know the temperature, you absolutely have to have the right tool and the right training to do so. So please understand that. But this is a great, I mean, being able to take these images and using them for mapping is really awesome and able to do that. But you've got to know how to use that. You've got to know how to do it. When we look at this image here, this image is actually a very large space. This was taken not with a UAS, but actually with a plane. It was stitched together radiometrically. This company went ahead and was able to make the data radiometrically put together and then process it. So another company that was able to do it, but when I see images like this and others see images like this, they think that the XT is going to be able to do this quite easily. These types of cameras are slightly different than the Tau 2 cores. They don't run the same. They're not the same. They provide the same images, but they are not the same. We did talk about this this image just a little bit earlier. When I stitched it into Photoshop and I took the actual pictures, that it only showed up in grayscale, and there isn't much else I can do with this image because most of the thermal imaging programs like FLIR tools or anything like that, you're not able to load it in after it's been stitched like this because the data has been lost. All it's been doing is, all it does is stitch pixels. That's all. So this grayscale type image is maybe helpful to a farmer that might want to look at some of the stuff there that we went out and took, but maybe it's not. You know, maybe they do need to see some variance in color, because the color you can see things pop out, seem to pop out a little bit better. Ron Knox, he asked a question: how do I tell the client he doesn't need complete radiometric of his solar field, but just to maybe troubleshoot or look at the trouble spots? So that's actually one of my more popular questions, Ron. Again, how do I tell a client he doesn't need complete radiometric data? So when I don't know, Ron, if you've actually seen the video that we created that was kind of based around a solar field. A friend of mine, Mark, and I went down there and actually worked with some OEM guys, showed them, and they were the actual operation and maintenance people. And when they walked out there with handhelds, they would walk to every single panel to try and get that temperature data from them, for them. We were able to fly the drone over so that we could, find a space that was a little bit closer, or find relative problems that were not so difficult to do by walking. And what typically takes them about, I don't know, what was that, Mark, 3 to 4 hours to walk around in the space, took me about 1 minute and 27 seconds to find the problems. And so just flying over, you're able to direct some of the guys. But if you need to chart or you need to put down thermal temperatures that are relative to that, you may have to incorporate to the client, hey, if you need this data, I can do XYZ. And XYZ is kind of dependent on the equipment that you currently have. So if you don't have a handheld, yeah, you're going to have to change your workflow a little bit. If you do have a handheld, you can create certain spaces and create a map that would be able to direct those people to those spots. Another question from Ron: does the FLIR 640R cameras come with a software package or tools? So the FLIR tools is typically the thermal imaging processing, if you will, the ease of use processing program in order to create reports and stuff. But remember that FLIR tools is typically only one image at a time. You can have somebody like Spark Aerial go ahead and stitch all of your radiometric data together and then process that in FLIR tools. But that being that every single picture is an individual file, you almost have to batch all those files, and unfortunately FLIR tools does not do that at all. But some of the software packages or the tools that are recommended to be used for single-use pictures, FLIR tools is the guys. What do you use for reports on data analysis? FLIR tools, as I had just said, is probably the single one picture to be able to do some of the reports and as well as show some of the thermal temperature if needed. Sometimes just using that JPEG data and that's it in a comparative analysis rather than a temperature analysis can be done in Photoshop or anything else that just is using the standard picture and not actual radiometric data. Ivan, can you recommend an online course for thermal imaging? So there is a couple of online courses that Infrared Training Center actually does. I'll put some links up here shortly on where you can get that, where you can go to actually try and do some education in the thermal part. Steve finds on your website there's a mention of a how-to XT video. Could you describe what that covers? I think I'd be interested in seeing it. So the XT video is just kind of walks through a little bit of the settings, a little bit of the emissivity values and whatnot, but I think I'll do a little bit more refined one once I get a good thermal stitching process kind of down with some of the companies that are out there. So it kind of just explains how to use it, how to run it. This one is from George Sickler. Are oil and gas using these inspections for site maintenance? Hoping to see the oil back in Northeast Colorado. So oil and gas are using them, but in a general sense, with the temperature sensing of things, their pipes, their lines, their stuff like that, they do ask for drone operators or handheld operators or thermographers to come out and look at those. Normally with oil and gas, they're looking for leaks though. They can sometimes see an actual expulsion of gas coming out of pipes, but once again, you're back to having to use an actual thermal camera, a gas camera to do that. So, and those are fairly expensive to do so. Pierre, my interest is in tracking wildlife for conservation work. XT performance is my best. I agree with that. If you don't need thermal temperature, I agree that you're doing any tracking wildlife or basically doing counting of livestock or anything like that. I think the XT is a great unit for that. Ethan, what courses do you recommend for basic understanding to work with clients in the industrial sector? Again, I would highly recommend at least just taking the Thermography 1 class in order to do and understand a little bit of the thermography side of things. Super important there. Just wanted to again thank a lot of the guys that were out there that had helped us get and gather some of this information to get out to you. We'll talk a little bit more about the image processing, mapping, setting up, and everything else that's out there and available to us currently, and what the market is trying to do to fix and work on that. So several different companies we're working on, and I will keep you posted on that. Thanks a lot, guys, for tuning in today. And if there's anyone else if you have any other further questions, please feel free to give me a call, rmus.com, or 801-316-3250. So be happy to help out, answer questions, and I'd like to thank Chad for pretty much doing nothing today. Thanks, guys.